So, have you heard about these fascinating developments in off the shelf cartilage for bone regrowth? They're really changing how we think about tissue regeneration.
Mm-hmm. Absolutely. This approach sounds revolutionary, using a cell-free cartilage structure to guide bone repair rather than relying on live cells from the patient, right?
Exactly. They
Yeah.
engineered a cartilage scaffold by first cultivating cartilage in the lab and then decellularizing it so only the extracellular matrix remains, which keeps those crucial growth factors intact to signal the body to rebuild bone.
That's really interesting because it means instead of having a variable patient-specific graft, they're aiming for a standardized, off-the-shelf solution.
Right, it's like an instruction manual for your body. The implant tells it, "Hey, start the bone regeneration process," while avoiding those nasty immune rejections that usually plague transplants.
Mm-hmm. Which is a huge plus. Current methods often require harvesting your own cells, adding extra procedures and unpredictability.
Yup, and the really cool part is that the decellularized matrix, with its embedded growth factors, acts like a blueprint, guiding your own cells to migrate in and lay down new bone.
Right.
Imagine it like a conductor leading an orchestra of cellular activity.
That's a great analogy. But I do wonder, could this one-size-fits-all scaffold ever miss the mark when it comes to individual biomechanical differences?
That's a valid concern. Yet, the study suggests that these fundamental biochemical cues seem universal enough, minimizing strong immune responses while performing consistently across different subjects.
I see. It's promising that in animal tests, the implant safely supported bone repair without provoking major immune reactions.
Exactly. And since it's produced in advance and stored, it could streamline treatments for the nearly 2 million people worldwide who need bone tissue transplants each year.
That's huge. The cost and time savings alone could transform treatment options. Still, I can't help but wonder if this fully addresses the underlying issues, like in complex cases involving osteoarthritis.
Fair point. While it does rebuild the bone framework, in cases with metabolic or systemic issues, it might only be one part of a more comprehensive treatment plan. Not a magic bullet, but definitely a major breakthrough.
That nuance is important. It's revolutionary for traumatic or localized damage, but may need to be combined with other therapies for diseases that affect the whole system, right?
Precisely. And the next phase is all about scaling up production, ensuring quality, and moving toward human clinical trials, with engineers and clinicians working closely together to make that happen.
That mix of bioengineering and clinical application is super exciting. It's like science is finally bridging the gap between the lab and real world healing.
Absolutely, it's a bold
Yeah.
step forward. The design of a ready made, off the shelf graft that could standardize bone repair is a game changer in regenerative medicine.
Well, I'm looking forward to seeing how this moves into clinical trials and how it might evolve further. Truly an inspiring time for regenerative science.